Number 7, we have the integral from 0 to 1 of e to the negative 4x dx. So u is going to be equal to negative 4x. du is equal to negative 4 dx. We have the dx, but not the negative 4. So we have the negative 4 on the inside, and it's reciprocal of negative 1/4 on the outside. So we're looking at negative 1/4, and there the integral. Negative 4x is replaced by u, so it's e to the u du. And if we plug 0 in for x, we get negative 4 times 0. If we plug 1 in for x, we have negative 4. Okay, so these bounds are backwards. 0 should be up top because 0 is greater than negative 4. So we can swap our bounds, which means we have negative 4 down here, 0 up here. This is still e to the u du, but we have to negate the integral, which means we have to negate the negative 4, which makes the coefficient out front now positive 1/4. Now we can go ahead and do our f of b minus f of a. So we have the 1/4 out front, and then we have e to the 0 minus e to the negative 4. Alright, well this doesn't identically match up with any of these at the moment, so we can do a little bit of work here. E to the 0 is 1, so we have 1/4, and then we have 1 minus e to the negative 4th. Distributing the 1/4, we have 1/4 times 1, which is 1/4, and then we have e to the negative 4th over 4. That matches up with D. We have number 8. This one is rather challenging. We have the integral from 0 to k of x over x squared plus 4. We have to figure out what k is equal to, which means we need to be given the answer. And we're told that our integral is equal to 1/2 natural log of 4. So we can go ahead and solve this stuff in an integral. We're just going to have k involved in our answer, which we're looking to solve. So if we think of this, we have u is equal to x squared plus 4, making du equal to 2x dx. Well, we have the x dx, but we don't have the 2. So we can put that in as long as we have the 1/2 out front. What does that mean? Well, we can change this into u, but I'm actually not going to do that. Now that I have the 1/2 out front, okay, I can go ahead and just take my antiderivative. I don't actually switch over to u. I could switch over to u, and I have to change my bounds, and it's going to make things a little interesting as far as the upper bound is concerned. So the idea being that we have x squared plus 4 in the denominator, and we have its derivative in the numerator, which means that when we take the antiderivative, we'll have the natural log of the absolute value of x squared plus 4. We have the 1/2 out front, and this is evaluated from 0 to k. If you had the natural log of u here, then this would be 4, and this would be k squared plus 4. It would work out the same, but I'm just trying to keep things as is in regards to x. We know that this is equal to 1/2 the natural log of 4. So now we have to figure out what k is. So we have to do our f of b minus f of a. When we do so, we plug in k first. So we have 1/2 natural log k squared plus 4. K is positive. When you square it and add 4, the answer is positive. So we don't really need the absolute value markers anymore, because this is k squared plus 4 is guaranteed to be positive. Minus, now we plug in 0. So we have 1/2 the natural log of 0 squared plus 4. So that's just 1/2 the natural log of 4. That's equal to the same thing as it was equal to before, 1/2 natural log of 4. Now we have an equation. We need to solve for k. Well, for starters, we can get rid of this 1/2 natural log of 4 by adding it to both sides. Alright, doing so wipes those out and gives us an entire natural log of 4 over here. On this side we have 1/2 the natural log of k squared plus 4. So now you're saying let's get rid of the 1/2. You'd be correct. We can do that by multiplying by 2. That brings the 2 over to this side. Just be careful. Alright, we have the natural log of k squared plus 4 on the left. We're multiplying it by 2, which means we have to multiply the right by 2. That's not the natural log of 8. It's twice the natural log of 4. Now we want to get rid of the natural log, and your brains are remembering from pre-cal that we have to use e. We cannot quite use e on this side yet because we have this 2 coefficient. which means that we have to move that 2 out of there. And you're saying, well, we would have to divide by 2, which would bring it to the 1/2, and we're back to where we started. That would be one way to get rid of this 2, but it's not the ideal way. One of your properties for logarithms that you learned in pre-cal said if you have a coefficient of a logarithm, that coefficient can be moved up into the exponent of the value that you're taking the natural log. In other words, twice the natural log of 4 is equal to the natural log of 16. Okay, and you can check this on the calculator. If you do 2 natural log 4 and hit enter, and then you hit natural log of 16, you'll see that you'll get the exact same answer. Okay, so we now have the natural log of k squared plus 4 is equal to the natural log of 16. We have the natural log leading off both of our equations, so we can raise both up into the exponent of e. That wipes out and brings both of our exponents, down to the base level. So we have k squared plus 4 is equal to 16. Subtract 4 from both sides, and we have k squared is 12, and therefore k is the square root of 12, which is d.